Hey everybody, what's up? So I bet you've always wondered what ketones, aldehydes, and all that other stuff was, right? You haven't? Hold on, let me see. Your teacher's all into these things and now you get to learn about them too? Yeah? Alright then. Then good thing you've got us to explain it all, huh? Well, what are ketones, aldehydes, and all that other stuff? When your teacher starts dropping these words, what they're talking about are some typical organic bonds to oxygen. So mostly bonds involving carbon, oxygen, and hydrogen. Now we're going to go ahead and have a look at some of the most important ones. Let's start with alcohols. The best example of an alcohol is ethanol, otherwise known as drinking alcohol. An alcohol is made up of an organic group like a hydrocarbon, just like different combinations of carbon and hydrogen bound to the hydroxyl group. A hydroxyl group consists of one oxygen and one hydrogen atom. The R here stands for residue and the OH for the hydroxyl group. Next we have ethers. The simplest compound in this case is dimethyl ether. An ether consists of two organic residues with an oxygen atom bridge. Our example here has two methyl groups bound to one oxygen. Easy, huh? Our next player up are the ketones. Probably the best example of one is acetone. These guys also have two organic groups with a kind of bridge between them. Except here, instead of a single oxygen atom in the middle, there's a carbon-oxygen double bond, and the carbon atom acts as a bridge between the two organic residues. The ketones' best pals are the aldehydes. Probably the best known and most widely produced aldehyde is formaldehyde. 21 million metric tons of this stuff is made each year. The structure that all aldehydes have in common is one organic group bound to a carbon that's bound to a hydrogen and double bound to oxygen. Okay, now these next ones are pretty special. They're called phenols. This one here is phenol itself, the compound that gives the class its name. Phenols are made up of a benzene ring with a hydroxyl group, which can be bound to any single one of the C's in the ring. Of course, you could also have other organic groups attached at other spots of the ring. Because of its benzene ring, phenol is also called an aromatic compound. If you want to know what makes aromatic compounds aromatic, go ahead and check out our video on the topic. Don't worry guys, we're almost done. So let's hurry up and look at carboxylic acids. These guys are like real acids. One example would be oxalic acid. Here you've got an organic residue with a carbon atom, which is double bonded to an oxygen atom and also forms a single bond with another oxygen atom, which is itself bound to hydrogen. Okay, we're as good as done. Here's the last one. Esters. This right here is an ester of carbonic acid. Esters are another class where there's a bridge in the middle. They connect two organic residues through a carbon-oxygen bridge. One of these organic residues is bound to C, and this carbon atom also forms a double bond with O and a single bond with another O, with the single bonded O bound to another organic residue. And there you have it, an ester. All of these functional groups and their compounds have one thing in common: oxygen. Because of the oxygen, they're relatively polar compounds, which distinguishes them from many other organic compounds that aren't polar. Due to their high polarity, almost all of them are ideal for use as solvents, as they tend to be used to make plastics, medications, disinfectants, and similar products. Alright, that does it. We're done. But don't let this stuff overwhelm you. Now, organic chemistry is a really complex subject, but it's really worth studying. In any event, you should remember that these structures we just learned about are going to show up again and again. These things are called functional groups. The ones we've just looked at are functional groups that contain oxygen bonds, and these are alcohols, ethers, ketones, aldehydes, phenols, carboxylic acids, and esters. Alright, that was our first look at organic chemistry with oxygen, but there are lots more cool videos on our playlist, so just keep clicking.